Hello and welcome to this video about matrix proofs. In this video we'll prove that every matrix is row equivalent to a unique matrix in reduced row echelon form. That is, it's row equivalent to exactly one matrix in reduced row echelon form. So now to start the proof, we prove it by demonstrating that any matrix can be gotten into reduced row echelon form using Gaussian row elimination. That is, a sequence of row operations that are used to get it into this form. So I don't want to show you row elimination again because you're probably already over familiar with it by now. I'll just describe some of the properties of it so as to prove the theorem. Its first property is that it will produce a unique series of row operations and therefore a unique series of row operation matrices, followed at the end by a unique matrix in reduced row echelon form. So I'll just write this out again using math symbols. There exists a unique series of matrices E1 to En and a matrix in reduced row echelon form which we can write as the RREF function of A, where the matrices E1 to En are row operation matrices, and RREFA is the matrix A in reduced row echelon form, such that the series of row operation matrices multiplied by A on the left will produce the reduced row echelon form of A. So this series of row operation matrices is unique. That is, there's only one sequence of these matrices, and the product of these matrices is the reduced row echelon form of A, and there's only one produced. So I'll write out that there is a unique matrix in reduced row echelon form for every matrix A in math symbols. So I could stop the proof here, but I'll mention some other points. The reduced row echelon form of the matrix is the final form of the matrix produced by Gaussian row elimination. So if you try to perform some new extra row operations on it to get another matrix in reduced row echelon form, it won't do it. This method of row elimination won't do anything to this matrix because it's already filled with pivot and free variable columns, so it can't be transformed into another matrix of this type using row operations. I'll just write this out mathematically. There doesn't exist a sequence of row operation matrices that can change one matrix in this reduced form into another of this type. Since Gaussian elimination works this way, then there is at least one matrix in reduced row echelon form for any particular matrix. So I'll just describe this function as doing that, producing at least one matrix in this form. And you can't get one matrix in this reduced form into another one of this form. So there is only one matrix in reduced row echelon form for every matrix, so that it's unique. And because there's a list of row operations to get it into this form, this corresponds to there being a list of row operation matrices. This is handy to write here because you might have listed a sequence of row operations made on the matrix rather than a list of row operation matrices that multiply this matrix to get it into reduced row echelon form. I'll just scroll up the screen here to make more room. And so this implies that this matrix is row equivalent to a unique matrix in reduced row echelon form. And so I'll just write this down mathematically. A is row equivalent to exactly one matrix in reduced row echelon form. And this function RREF gets it into this form, and it's a function because it outputs one element for any input. So I hope that you found this video to be in some way helpful. I know I didn't describe the Gaussian elimination process in detail, which I probably should have. If you want to use this proof in an exam, then talk to your teacher about it. So if you did find it helpful, then please click like and subscribe. Feel free to post up any helpful comments and to share this video, and thanks a lot for watching.